All right, this is lesson 8, polynomials, graphing linear equations, and the intercept-slope method, which I will call the slope-intercept method. First of all, with this lesson, there's some terminology that you need to know, so let's talk about that first of all. The first word is a polynomial. A polynomial is, it's like an expression, like in English, how you have sentences and then you have fragments, you have clauses and phrases. Polynomial is not a complete sentence. So a polynomial is just a group of terms put together. So I'll just show you some examples of a polynomial. So we have -4 would be an example, 1/2, 2x. We might have something like -5x squared plus 6x plus 2. These are all polynomials. Couple things: there are no fractional or negative exponents in a polynomial. They're just called simple expressions. Now there's specific types of polynomials, like a monomial is a polynomial with just one term. This one-term polynomial, so an example of a one-term polynomial would be these are all one-term polynomials, or you could have something like 0.004x to the 5th is a monomial, or the square root of 2x, monomial. So those are all monomials. They do have variables like this one, the -4x. It's really -4x to the 0 power, so it's still a monomial. It has a variable in it. A binomial is a two-termed polynomial, so it might be something like x plus 2, or x to the 4th plus 2x. They are two-termed polynomials, and they're called binomials. And then finally we have trinomials, which are three-termed polynomials. So an example of that would be 2x squared plus 3x plus 4. Now you notice here, this is a trinomial. It's like a tricycle, has 3 wheels. So a polynomial with 3 terms, these are all called terms, is called a trinomial. Now each polynomial has a degree. How do you determine the degree of a trinomial? Well, you determine the degree of each term, and then the highest term wins. So the degree of this one would be the highest, would be 2 of this term. The degree of this term, the highest exponent, is 1. So the degree of this term is 1, and the degree of this is 0. So the degree of this trinomial, you would say, is 2. So this is a second degree polynomial. There's also a thing called a polynomial equation. It's an equation that contains polynomial terms, and the degree of the polynomial equation is the same as the degree of the highest term. So let's just do a polynomial equation. So it would be something like this: 4x to the 3rd plus 3x squared plus 4x plus 1 equals 0. That has an equal sign, so it's called a polynomial equation. The degree of this would be the degree of the highest term, which is this one. So the degree of this polynomial equation is 3. Now this is going to come into play when we do some problems and we need to know what the degree of the equation is. So keep that in mind. So that was the first part, just about polynomials. The second part of the lesson is how to graph linear equations. This is one of the most important things that we're going to do this year, especially as you take the SAT and take standardized tests. There's going to be a lot of equations. We're going to do 2 methods in this video. Hopefully the video is not too long today. The first one is making a table, which you're not going to do very often in Algebra 1 anymore, but you still need to do a table for when we graph things that are not linear. So what we're going to graph today are called linear equations, and that means that they have a degree of 1. And when they have a degree of 1, our equations, if you look at it right here, the highest degree is a 1. So it'd be x to the 1, y to the 1. So that's called a linear equation in degree 1. So I'm going to write that down. You should write this down. Linear equations have a degree of 1. So if you see an equation with the highest degree of 1, you know it's going to be a straight line. And that's why they call it a linear equation, because it's going to be a graph of a straight line. So how do you graph them? First thing you want to do is solve the equation for y. So I'm going to come down here and do this as we work through the steps. So we're going to get 3y. I'm going to subtract 2x from both sides, so it's going to be negative 2x plus 6. And then we're going to divide every term by 3 so that we can get the y by itself. So you're going to get y equals negative 2/3 x plus 2. That was our first step. Solve for y. Now we're going to make a table like such. And we're going to pick some, it says right here, convenient values for x. So you don't want to pick something like 200, that's not convenient, but you want to think about it a little bit. And typically on a table, I like to pick 3 values. So I'm going to go over here and just put some lines, axes on my graph. So that's the x-axis, and this is the y-axis. And when you do your axes, I want you to label them. You're going to put arrows on these ends. This is your y-axis, and this is your x-axis. Usually you just put arrows on those ends. I'm not sure why, but if you like to, you can put them on all the ends because they go on and on and on forever. So those are your axes. I'm going to pick some convenient values for x, and one of the convenient ones I always pick is 0. I always think that's very convenient. That's going to give you your y-intercept. When x is 0, that's going to tell you where to put the dot on the y-axis. So if I put a 0 in there, I'm going to get a 2 out, first point. Next convenient one, notice it's a fraction. So I'm going to pick 3 because the 3's would cross out right here, and I would have negative 2 plus 2, I would get 0. Convenient because it's a fraction, I can get rid of the fraction. The other convenient one I say is negative 3. So I put the negative 3 in here. They're going to cross out, but it's going to make it a positive 4 and positive 2. And so we're going to get 2 plus 2 is 4. So hopefully you were tracking with that. What I did was I took 2/3 times negative 3 plus 2. These crossed out, but then I got a positive 2 plus 2, and that gave me the 4. So once you get your table of values, then you're going to graph these ordered pairs. There are points. There's an infinite number of ordered pairs on a line. As you could guess, we could put an infinite number in for the x values and get points. So I'm going to go over here and graph it. So we got 0, 2. We have 3, 0. And we have negative 3, 4. Okay, hopefully I counted that right. Little things are so small. If they don't line up, then one of your numbers is wrong. That's you evaluated one of them wrong. So that's why we always do 3. 2 points determines the line, and the 3rd point checks it. And then I'm going to take, I'm really bad at this, connecting my points with a line. That's not too bad. All right, so you connect them and put arrows at the end of your line. It's not like they don't end. This goes on and on forever and ever and ever. So that's how you graph a line using a table. Now in Algebra 1, we're not going to graph our lines using a table, but you're going to need to make tables to graph other things. Like when we graph different types of higher degree polynomials, you're going to need to make a table. All right, next part is graphing using the slope-intercept method. Now this is the slope-intercept form of a line. We have y equals, this has to become a friend of yours, y equals mx plus b, where m is the slope of the line. Whoa, the internet must be going because I'm having trouble writing in my battery. You can do this for your fun fact, for your extra credit point, is my battery is going dead on my computer. I might have to stop and go get my cord. And this is your y-intercept. That's where it's going to cross the y-axis, because if you put a 0 in for x right here, 0 in for x, it's just going to give you b. So everyone needs to hold on for 1 second until I get my charger for my computer. Okay, I got my cord, so it should work better. Okay, so let's graph these things. You need to follow the steps. The first thing is you want to make sure that your equation is in the form y equals mx plus b, which this one already is. They're so nice to us. Then we're going to note the y-intercept, which is the b value, and the y-intercept means where it crosses the y-axis. So again, I need to put my axes on my graph. So here we go. It's just like a gray, so it's hard to see. So I'm going to put my gray lines on. And what do we always do? We take and we put our arrows and label our axes, the y-axis and the x-axis. All right, this is a lot easier than making a table. So I hope you can learn this quickly and use this all the time. So we have to put in the form y equals mx plus b. As I said, this will be a friend. We're going to use it a lot. We're going to find the b. So you track up to your equation. Where's the b? Well, the b is this -3, which is, if x is 0, even if you think about your chart, y is going to be -3. So we're going to put a point on 1, 2, 3, -3. This is way easier than the chart. And then, so our b is -3, which is our y-intercept. All right, excuse my writing on this. I can't write very neatly. And the m stands for your slope. So your slope is -3. It's the number before the x. So you always make your slope a fraction because slope is rise over run. So you start at your y-intercept. You don't start at 0, 0. Start at your y-intercept, and it's rise over run. So we're going to go down 3. 1, 2, 3. I rose -3 and I ran 1. So I'm going to connect that. That's all you really need. You can connect those 2 points and you'll get your equation of a line. What I recommend is you can do more than one. Start here. You can also rise 3 and run -1. It doesn't matter where the negative sign is. So I'm going to try that this time to see if I line up on the same line. So I'm going to go up 1, 2, 3 and go -1 this time. So you can see that they all line up on the same line, and we take our line and we connect it. And it's working out for me pretty well today. Okay, and here we go. Put the arrows on the end of the line, and you just graphed a line without using a table. We use the slope-intercept method of graphing the line. Some things they don't teach you in Algebra 2 because you learned it in Algebra 1 is you'll notice this line is y equals -3x minus 3. The slope is negative, which means if you're going from left to right, it's going to be going downhill. If it's a positive slope, if you're reading like you read normally from left to right, it's going uphill. If your slope is equal to 0, it means it's going to be a horizontal line. And sometimes your slope is what we call undefined, like if you had something like 3 over 0. You can't divide by 0, so your slope is undefined, and that means it's going to be a vertical line, your undefined slope. So lots of things about lines. We're going to be dealing with lines fairly frequently. All right, here we go. Hopefully you can still see in your paper the steps, so I'm going to run through them here. So first of all, solve it and put in the form y equals mx plus b, where m is the slope and b is the y-intercept. So we're going to get 4y, subtract 3x from both sides, plus 8, Now I'm going to divide everything by 4. So we get y equals negative 3/4 x plus 2. Again, we have a negative slope. So first thing you want to do is identify your b, which is your y-intercept, and that's 2. I need lines again on my graph. So here we go. I know it seems like a pain to every time label your axes, but you want to have good form. Good form is important for mathematics. So we have our y-axis and our x-axis. And we're going to put, first of all, we're going to put the 2 on. So that's our x-intercept. If I put a 0 in for x, this is 0 for x, I would get, whoops, down here, I would get the 2 for my y-intercept. Now, your slope is negative 3/4. That's your slope. So you're going to rise negative 3, and you're going to run 4. Or you could do 3/4 like this and put the negative sign down there, and you would rise 4 and go to the left, rise 3 and go to the left 4. So let's do it both ways. So I'm going to start at the y-intercept. I'm going to go 1, 2, 3, 1, 2, 3, 4. There we go. And I'm going to go the other way. Up 3, 1, 2, 3, 1, 2, 3, 4. You can keep going and going and going because in between any 2 points on a line, the slope is going to be the same. I could start down here and go 1, 2, 3, 1, 2, 3, 4. And I could go from this one, 1, 2, 3, 1, 2, 3, 4. So you can just keep going and going and going. You could use 2 points. I recommend 3, but you can do more if you want to be sure. So we can connect those, possibly. It's going to be hard for me to get down through all of these. But guess what? When the slope's the same, it's pretty easy. And put arrows on the end because that's good form. And we just graph the linear equation. Remember, linear is a first degree equation. The highest degree is 1, and it's going to be the graph of that line, of that equation, is going to be a straight line. So sorry that was kind of long, but it was necessary. So that's it for all the lessons for this week, and we'll see you in class on Thursday.